Welcome to MathMinders Academy. If this is your first time joining our channel and you are yet to subscribe, smash the subscribe button, hit the notification bell so that each time we release a new video, you'll be among the first to get it. Like, share, and comment on this video. Let's go. So today we are going to look at how to find the volume of a casting. Sometimes we are given an object that is made from material. After the casting, we may be required to find the volume of the materials used in this very object. So we are going to look at a typical example of a casting in the form of a pencil. Here, when we look at this object, you'll discover that this object has been built with some mathematical shapes like cylinder, shapes like hemisphere, shapes like cone. And so how can we determine the volume of the material used in this casting? That is what today's video is going to explore. So join me while we look at a typical question that will help us to consider the volume of this casting. So here we are given a question that a casting in the form of a pencil has a total length of 20 centimeters and consists of 3 parts: a cylindrical body, a conical top, and a hemispherical eraser. The radius of both the cylinder and the hemisphere is 2 centimeters. The height of the conical top is 3 centimeters. We are required to calculate the total volume of the material used in the casting. So let's look at the object in view. This is the object. Now, it has 3 parts. It has the cylindrical body, which we are going to look at. The entire object measures 20 centimeters in height, or the length, 20 centimeters. But here, we can see the cylindrical body. So this object has a cylindrical body. And then outside that, what other shape can we see? Look at the top. It has a conical top. All right. Then let's look at the bottom, which is the eraser. This is a hemisphere. This is a hemisphere. So we are going to be looking at how to use our knowledge of the volumes of each of these shapes to determine the volume of the material used in this casting. So we proceed to break this object into the different solid shapes that are combined together to form it. So we have the conical top with a height of 3 centimeters. Now we have the hemispherical bottom, which is acting as the eraser, and that comes with a radius of 2 centimeters. And we have the cylindrical body. And this cylindrical body here is 15 centimeters. How did we get this 15 centimeters when we are told that the entire length of the object is 20 centimeters? So we are going to find out how we were able to come about these 15 centimeters. Here, the height of the cylindrical body is the length of the entire object, which is 20 centimeters, minus the height of the conical top, which is the 3 centimeters, minus the radius of the hemispherical bottom, which is 2 centimeters. So if we do 20 minus 3 minus 2, that gives us 15 centimeters, and that would be the length of the cylindrical body of this casting. We now proceed to look at how to find the volume of this casting. So the volume of this casting is going to be the volume of the conical head plus volume of cylindrical body plus volume of hemispherical eraser. So these three volumes will be added together to give us the volume of the casting. So the formula is showed on your screen now. For the volume of the conical head, we have 1/3 times pi times the radius of this cone squared times the height of the cone, plus pi times the radius of the cylinder squared times the height of the cylinder, plus 2/3 times pi times the radius of the hemispherical eraser raised to power 3. So we are going to substitute all the values into these different formulas to determine the volume of the material used in this casting. So looking at the first bracket, which represents the volume of the conical head, we have 1/3 times pi is 22/7 times the radius of the cone is 2, as we have discussed. So we raise that radius to power 2. Then the height of the cone is 3. And then we go to the second formula, which represents the volume of the cylindrical body, 22/7 for pi, times the radius of the cylinder is 2. So we raise it to power 2 times the height of the cylinder, which is also the length in this instance, is 15. Then the last formula represents the volume of the hemispherical eraser, which is 2/3 times pi, and pi is 22/7, times the radius of the hemisphere, which is 2. We raise it to power 3. So we look at what each of these will give if we evaluate them separately. So if we evaluate the first bracket, we have 88/7 plus 1,320/7 plus 352/21. This will amount to 4,576/21, and this will be 217.9 cubic centimeter. This represents the volume of the material used in this casting. So guys, we've come to the end of this tutorial. Did you enjoy it? If you find value in today's tutorial and you are yet to subscribe to our channel, go right now, smash the subscribe button, hit the notification bell icon so that each time we produce a new video, you will be among the first to receive it. Go to the comment section, tell us what you feel about this video. Let us know the topics you want us to develop videos on. Next time, we are going to work on another interesting topic, and I'll be looking forward to seeing you in our tutorial class. This is MathMinders Academy saying goodbye for now.
In the midnight glow where the stars align, we lose ourselves in the rhythm divine. Underneath the sky painted with dreams, we're chasing the echoes of silent screams. Caught